এটা কিন্তু খুবই ডিফিকাল্ট আছে। আরো
গুড
অন্যান্য
গুড গুড
আরো অন্যান্য
সার্কিটের
কিছুর দিক
গুলো,
দিয়ে
তাই না?
আমরা পিছিয়ে আছি।
হ্যাঁ, সার্কিট থাকে, তারপরে লজিক গেট টেট এইগুলো থাকে। আমি আসলে ডিপ্লোমা
হ্যাঁ,
করছি তো
হ্যাঁ,
জানি না।
প্রোগ্রামিং আছে। তারপরে আমাদের তো এখন প্রোগ্রামিং ধরতেছে না। ফার্স্ট সেমিস্টার তো ধরবে না,
প্রোগ্রাম
এরপরে
আসলে
ধরবে না।
প্রথম সেমিস্টারের প্রোগ্রাম থাকে না, কোনো জায়গায় থাকে না প্রথম সেমিস্টার।
রেফারেন্স
না
করাইতেছে নাও
না
বাংলাদেশে।
বাংলাদেশের
প্রোগ্রামিং
কথা বাদ রে ভাই, বাংলাদেশের কথা আলাদা।
হ্যাঁ, হ্যাঁ, অনেকটা দেই। মানে বেসিকটা অন্তত দেই, ওদের কয়েকটা জিনিস দেই আমি শুনছি। হ্যাঁ, হ্যাঁ, হ্যাঁ,
কি কমই
এটা
আমাদেরকে পড়ায় না নাকি বেসিক? আমাদেরকেও পড়াইছে বেসিক, ওয়াইফাই সম্পর্কে পড়াইছে, ব্রডব্যান্ড সম্পর্কে পড়াইছে, এগুলো কি বেসিক না অনেকে?
বাট
হ্যাঁ, কি
হুম,
কম
হুম, এক্স্যাক্টলি,
ওগুলা
এগুলো বেসিক, এগুলো বেসিক।
সি প্রোগ্রামের বেসিক না হইতে, কিন্তু আমাদের বেসিক পড়াইছে কিভাবে ওয়াইফাই চালা লাগবে, কিভাবে ওয়াইফাই কানেক্ট করা লাগবে। কম্পিউট, ইউ নো, ইয়া, কম্পিউটার, কম্পিউটার, ইয়া, ইয়া, রাইট, ইয়া,
মোস্তাফিজ,
হ্যাঁ বলো।
আমাকে শোনা যায়?
হ্যাঁ হ্যাঁ, অবশ্যই, না হলে আমি অ্যান্সার দিচ্ছি কিভাবে ভাই, বলো।
দারুন।
আচ্ছা,
ম্যাথ ক্লাসে আমি থাকবো না, রেকর্ডিং অন করে দিয়ে চলে যাবো, পরে বোঝাই দিস আমাদের কেউ।
কই যাইবা?
ভাই তুমি তুমি নিজেই বুঝতে পারবা।
আরে না, আমি ম্যাথ পারি না ভাই, আমি ম্যাথ পারি না।
সেম সেম ভাই, আমারও একই অবস্থা। হ্যাঁ, ম্যাথে আমারও একই অবস্থা।
এ ভাই শোনো, তুমি তো
ও,
পলিটেকনিক থেকে এসছো, আমি এইচএসসি স্টুডেন্ট, ইন্টারের। আমি
আরে
ম্যাথ
ভাই,
স্কিপ
আমি
করে আসি।
আমি আমি তোমার হলো ইয়ে করছিলাম।
শোনো, আমি
বলছি
ম্যাথ
ঠিক আছে
স্কিপ
ভাই,
করে
আমার
আসছি।
আমার ব্যাকগ্রাউন্ড কিন্তু আর্ট ছিল, ঠিক আছে।
আর
আর্ট ছিল
যাই হোক,
আমার
আমি
background।
ম্যাথ স্কিপ করে আসছি ভাই, স্কিপ করা বুঝো, ম্যাথ স্কিপ করে আসছি, ম্যাথ করি
আর্টস
নাই আমি।
থেকে
হুম, হ্যাঁ
মুস্তাফিজুর ভাই, আর্টস থেকে বাংলাদেশেও করা যায় কম্পিউটার সায়েন্সে?
না,
হ্যাঁ, কেন যাবে না?
কি কি কি?
আমি আমি তো আর্টসে ছিলাম, আমি হলো ইয়েতে আর্টসে পড়তাম, তারপর ওখান থেকে ডিপ্লোমা করি, ডিপ্লোমা করে এটা এখন সরকারি। বেসরকারি কেন করবো? হ্যাঁ, কেন দিবে না? তুমি যদি
কি
চান্স
বলো?
পাও তাহলে তোমারে দিবে। তোমার
তাহলে
চান্স পাও।
আরে হতে পারে, জানা নাই।
আমরা তাইলে এত কষ্ট করে সায়েন্স পড়লাম কি জন্য? তোমরা যদি
না না
সবাই
না
পড়তে
ভাই,
পারো।
কষ্ট না,
জীবনটা
কষ্ট না ভাই,
বেদনা,
কষ্ট না।
জীবনটা
ভাই
বেদনা
কোনো
ভাই।
কিছুই ভাই, তুমি হয়তো ভাবছো যে হলে আমরা এখানে সিএসটি করছি, আমাদের কিন্তু ফিজিক্সও আসতে পারে, হ্যাঁ। হয়তো বা অনেকে
হ্যাঁ,
ভাববে ভাই ফিজিক্স কেন আসবে এখানে। ভাই
অবশ্যই
ফিজিক্সের
আসবে।
অনেক অনেক দরকার আছে, অনেক অনেক কিছু আছে ফিজিক্সের,
আমাদের
যেগুলো
ফিজিক্স করাবে রে ভাই, সামনে
এটা
ফিজিক্স আছে।
করাবে, এটা
আছে।
করাবে। কেমিস্ট্রিও থাকতে পারে এক সেমিস্টার মেবি, কারণ আমাদের আসলে
হ্যাঁ,
আমি এটা বলছি
বাংলাদেশি সিএসসি তে আছে, বাংলাদেশি সিএসসি তে আছে।
হ্যাঁ হ্যাঁ, সেটা কেমিস্ট্রি আছে বাংলাদেশে।
ইয়ে ভাই,
সবকিছুই ভাই, আর ইলেকট্রিক্যাল বা ইলেকট্রনিক্স এর দুইটা মানে এই সাবজেক্ট গুলো থাকে, যেমন লজিক
হুম,
গেট আছে বা সার্কিট আছে, এইগুলা থাকে, বিভিন্ন
হ্যাঁ,
ইয়ে
হ্যাঁ,
থাকে।
সার্কিট।
হ্যাঁ, অপারেটিং সিস্টেম, তারপর হার্ডওয়্যারের ক্ষেত্রে এগুলো থাকে, সার্ভিল্যান্স সিকিউরিটি সিস্টেম।
আমার কখনো এগুলা বদ্ধ, এগুলা পড়াকুর কত বাধ্য, সব সব জিনিয়াসের বংশ তোমরা। কথা
এগুলো
হইতেছে,
মজা রে ভাই, এগুলো
আরে
খুব
মজার
মজা
কথা
পাওয়া
বাদ
যায়
দাও,
এগুলা।
মজা বাদ
কেন?
দাও, আমার কথা শোনো। আমি
হ্যাঁ,
পড়ালেখায় আমার আমার যেটা লাগবে আমি সেটা পড়বো, আমার অন্যগুলো আমি ফেল হয়ে যাক, আমার ওগুলো গ্যারান্টি। কথা
ভাই
হইতেছে
ভাই,
যে সেমিস্টার,
আরেকটা কোশ্চেন আছে ভাই।
না না, আমি কব, কথা
না
হইতেছে
তুমি বলো ভাই, আমি তোমারই করছি।
না,
মানে
ওইটাই।
আজকে
কথা
আজকে
হইতেছে
টিচার
যদি,
যেটা বললো না, যে
বল
মানে
তুই আগে বল,
কোন, ভাই ভাই আমি বলি প্লিজ, এটা আমার জানা দরকার।
বল তা বল বল বল।
বলছি না ভাই, বলছি, একটু ওয়েট করো।
আরে তুই
মানে
বল তো ভাই।
50টা না কটা সাবজেক্ট আছে জানো, এটা মানে বেছে বেছে নেওয়া যায়, এরকম কোনো ইয়ে কি তুমি
আরে
জানো?
হ্যাঁ, ক্রেডিটের জন্য, ক্রেডিট ওটা সেকেন্ড সেমিস্টার থেকে, থার্ড সেমিস্টার থেকে শুরু হবে মেবি।
হ্যাঁ, দেখছো, এটা তুমি বলতে পারছো, তার মানে তুমি জানো। হ্যাঁ, এবার তুমি কন্টিনিউ করো তোমার কথা।
আরে আরে তুই ক্রেডিট যদি বাড়াতে চাস এমএসসির জন্য, তা তুই সাবজেক্ট নিতে পারবি না, ওখানে তো ফিক্সড নেই,
ও,
ক্রেডিট
আই
বাড়াইতে
সি,
পারবি না।
ওকে ওকে, বুঝতে পারছি ভাই, থ্যাংক ইউ।
তোর ক্রেডিট বাড়া যায়, সাবজেক্ট না যায়, তোর ওখানে যা, ওখানে গিয়ে তোর কংফু একটা শিখবি, ওটার একটা ক্রেডিট আছে, ওটারও ক্রেডিট আছে। এখন আমার কথাটা শোন এখন। কথা হচ্ছে যদি আমি ইয়ার চেঞ্জে ইয়ারলি এক্সামে যদি ফেল করি, তাহলে সেক্ষেত্রে কি হবে? পেড করে পড়া লাগবে, ফুল পেড করে, না ওই এক্সাম তো মানে
তো
তো
ওইটাই দেওয়া লাগে।
আমি সেকেন্ড ইয়ারে প্রমোশন পাবো, দিয়ে ওখানে আবার রিটেক দেওয়া লাগবে।
হুম 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 হুম।
তার আগে আমাকে সেকেন্ড ইয়ারে প্রমোশন দিবে না? আমি যদি ফেল যদি ফেল করতে থাকি, যদি ফেল করতে থাকি
আস্তাগফিরুল্লাহ। কয়বার ভাই, কয়বার এটা
আরে না,
কয়বার?
আমি খুঁজতেছি কি জানো, যদি দেখে যে ফেল করছি, এখন আমাকে প্রমোশন দিলে আমাকে এখন পেড করে পড়া লাগবে। ওটার দরকার না, আমি পেড করে পড়বো ভাই, আমি আর এক্সামই দেবো না ওটা।
ও আচ্ছা।
আমি ওটা বলতেছি।
এ আছে আছে ওইরকম 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 কিছু কিছু চায়না ভার্সিটি আছে, কিন্তু
এই
আমাদেরটা
তুমি
আছে কিনা জানি না।
তুমি কি তাহলে ফ্রি ফ্রি পড়াশোনা করতেছো? মানে
আরে না,
সিএসএস
আমি তো পেড করে পড়তেছি, কিন্তু আমি এক্সট্রা পেড করতে রাজি আছি। টাকা কি ভাই, হাতের ময়লা, আজ আছি কাল নাই, বুঝছো না?
টাকা সিনেমিনি খেলে, হ্যাঁ?
না না
টাকায় আমার সিনেমিনি করে, টাকায় আমার সিনেমিনি করে, টাকায় আমার সিনেমিনি করে।
তা দুটো
মানি,
ছিল প্রবলেম।
মানি ইজ ইকুয়াল পাওয়ার ব্রো।
দিস ইজ মাই পাওয়ার।
বাইক, ভাই, বাইক, বাইক আপাতত ঠিক আছে ভাই, বাইক আপাতত ঠিক আছে, ছেলেদের জন্য বাইক আপাতত ঠিক আছে, সুজুকি ঠিক আছে ভাই। দূর চাইছো কা? এ, যদি জিএফ থাকতো তাহলে এতদিনে নয় গাড়ি নিয়ে দৌড়িতাম, বুঝছো না? কিন্তু এখন সিঙ্গেল নিয়ে এখন বাইক নিয়ে দৌড়ে লাগে, বুঝছো না? বাইকে ঠিক আছে।
আপাতত আপাতত আমরা আপাতত আমরা সাপিউরের জেবটাকে নিয়ে একটু বাইকে নিয়ে ঘুরি, কি বলা যায়, ঠিক না?
হ্যাঁ, তাহলে ঠিক আছে। ড্যান্সিং, ড্যান্সিং কার।
ওকে ওকে ওকে, যাচ্ছি।
ডিসি, মার্ভেল, অলওয়েজ মার্ভেল, মার্ভেল, মার্ভেল। স্পাইডারম্যান নো ওয়ে হোম, ইয়েস ব্রো, ডাই হার্ড ফ্যান, অ্যাভেঞ্জার, অ্যাভেঞ্জার্স। আরে স্পাইডারম্যান নো ওয়ে হোম 10 দিনে 1.1 বিলিয়ন প্লাস ইনকাম করছে। মার্ভেল ইজ ব্যাড, ডিসি গ্রেট। Bro, let me tell you something. I love Marvel, but if you say about DC, I love Superman more than Marvel. Superman more than Marvel, but Marvel is OP. Wow. No, no, Wonder Woman. Superman, Superman is great. Superman, only one Superman can beat Thanos. Underpants. আর না, এখন শিখছে মিয়া। নতুন সুপারম্যান দেখো না, ম্যান অফ স্টিল, ব্যাটম্যান ভার্সেস সুপারম্যান, ডাউন।
সাবিউর,
তাই হার্ট।
তুমি কি তাহলে বাইকে ঘোরানোর জন্য দিচ্ছ তাহলে আমাদেরকে?
মাঝে মাঝে ব্রেক মারবো, সমস্যা হবে না তো? নিউ ব্যাটম্যান ইজ কামিং ব্রো, নিউ ব্যাটম্যান ইজ কামিং। এই টি-শার্ট, টি-শার্ট নিহাও লাভছি।
লেখাচ্ছি।
মাইকের আওয়াজ কি পাইতেছিস নাকি রে তোরা? পাইতেছিস, অবভিয়াসলি পাইতেছিস।
Hello,
নিহাও লাভছি,
hello everyone.
নিহাও লাভছি, নিহাও লাভছি।
ইন হাউ লাউছে।
Hello.
হ্যালো,
হ্যালো,
Hi, can you hear me?
ইয়েস
yeah,
লাভছি।
we are hearing you.
Okay. Okay, we begin the color. Okay. I think you can see the screen.
Yes, Laushi, I'm present. I'm the first one.
The first one, Hồ
Yes,
Sai
Laushi.
Tớ.
Yes, Laushi.
Hello, the first one.
Yes, Laushi, yes. It's me, first one.
I can't hear you. Oh, okay, present. The second.
Yes, Lausi, it's me, 210.
Yes, I can hear you. Why? I don't know why. Okay, now maybe you can send the message. I don't know why I cannot see you. Okay, maybe
Yes, Lausi, it's
there
me.
is a lot of noise in our classroom and I turn off it. Wait a moment.
বুঝলাম না।
ভাই থাকো, আমি গেলাম, ক্লাস করো। রেকর্ড অন করে দিয়ে গেলাম আমি।
Hello, Lausi, can you help me?
How to turn up? How to turn up?
স্পিকারের সমস্যা অনেক। হ্যাঁ,
Maybe there is a problem. I don't know. I can't hear you. Right? Because I don't know. Yes, I can hear you.
ওকে।
I can hear. Oh, hello.
Yes, we hear
Oh,
you,
you can
teacher.
hear
We hear you.
everyone. I
Yeah,
think
we're
so.
hearing you.
Now
Miss,
you can hear me.
can you hear us, Miss?
Now you are yelling. The second one.
Yes, Lausi, it's me.
She can't.
Please send the message because I can't hear you.
ما تسمعنا غادي تسمع داكشي اللي داير لنا.
Okay. Tap everyone.
باش نلقاو
Okay.
ما حتى واحد المكان.
Okay, this one.
It's me. It's
It
me.
appears my problem. I don't know how to fix it. I don't know how to fix it because you can hear me.
We can hear you, teacher. We can.
Can hear.
Laushi, it's me.
We can
Yes,
hear you,
you
Miss.
just tap
She
right
can't hear you.
here.
It's me.
Just type. She can't hear you. She can't
Laushi,
hear
it's
you.
me.
He is present. He
Type,
is
type,
present,
type a
teacher.
message. Type a
Change my
message.
earphone.
She can't hear you.
Change my earphone. Have a try. Change
No,
my
no,
earphone.
এসএমএসটা সেন্ড করছে না। এটা দরকার।
Hello, now.
Trade your
It's me. It's
coins.
me. Wow.
She can't hear you. Wow, she
They
can't
can
hear you.
hear.
Type it.
I change it. Oh, now can you hear me?
Yes.
Present
Yes.
teacher.
Yes, we can,
You are,
teacher.
yeah. Okay, present.
يا ما تسمعناش.
Yeah, it's you. I can't hear you. I still can't hear it. You just tap your ID, okay? And you center here are present.
Yes, Laushi.
18.
Yes, Laushi.
Hello, 18.
Yes, Laushi.
18. Hello. 18 is not here, right? You are here. Okay, next time quickly. Because I can't hear you. You should send the message. Ilya. Ilya.
I'm here. I'm here.
Hello, Ilya. Lily is not here. Hasimu. Present. Okay. Kausa. 13. Present. Okay. This one. 09. Present. Okay. Sabater. 11. Okay, here. 07. Okay. 20. 1220. Hello, 20. Hello, 20. It's not here. 020. Okay, you send the message. Because I can't hear you. I can't hear anyone. 07. Okay, present. 艾特. 艾特. Okay. Next, 06. Okay, here. Number 10. Hello, number 10. Oh, number 10 is here. Okay, I see you. Number 4. 1204. Number 4. Number 4. Hello, this boy. Number 4. Maybe not here. Number 5. 05. Okay, present. Amy. 03. Hello, 03. You are. Okay. 欧舒文. Hello. 欧舒文. Okay, here. Next, Lele. Okay. Amos. Here. 16. Here. 15. 02. Hello. 03. Okay. 04. Okay. 08. Hello, 08. Hello, 08. Over here. Next. 01. 09. Please change your name, okay? This. I said you should name it by your ID. Because you say you are here, I don't know which one.
Baba Mom.
09 here, right? Oh, you say you're okay. Now this means this one is not here.
ولا ماما بترسف.
Okay, 12 here. Okay, Yulian here. Now take it. Second time. Then back. Please change your ID. Please change name it by your ID. I don't know which one. You are here. I don't know which one is you. 19. Hello, 19. Zembe is not here.
I'm
Ili.
present, miss. I'm present. I'm here. I'm here, miss.
Hello, Ili.
I'm here.
اكتب ليها اكتب ليها راه ما تسمعناش.
سمعك الشاش.
اكتب ليها صاحبي. اكتب دغيا
Okay, Ili is here.
صافي صافي.
ليلى الياس كيوت.
104. Zero 4. Which one is 09? Why do you change your name? 04. Huamin. Now quickly, Huamin. Okay, upper class. Okay, you should wait. I will. Which one is you? This
হামিম
one.
কোথায় তোফাইল?
Okay, you can. 09 is here, right? Which one? Your ID is which one? 6209 576209。208。Check it again, okay? Number 19 is not here. 1204 is not here. Right? And Huamin is not here. Right? Okay, we are. This is code. I think it's code. No? Hey. Oh. Okay, begin our class. Do you remember what we have learned last time? Remember? Okay. Last time we have learned how to find the maximum and the minimum values, right? Lots of noise. And we have learned the extreme values. critical point. Now, do you know critical point? Do you know critical point? This means we have stationary points. Critical point includes stationary point, singular point, and end points. Right? This is a critical point. We have critical point theorem. Last time we learned theorem B. This is the FC. FC is an extreme value. Then C must be a critical point. That is, either C is an end point of I, a stationary point, or a singular point. Then we have learned how to find the maximum and minimum values. This means we just find the critical points or critical points, and we calculate the evaluating f at the critical point, and the biggest is the maximum value, and the smallest is the minimum value, right? And we also learned the monotonicity and concavity. F is increasing. If f prime is positive, if f prime is positive, first the derivative is positive, this means it's increasing. And if the first derivative is negative, this means f is decreasing, right? But how to get the concavity? We have learned concave up and concave down. Concave up and concave down. This means concave up. This means if the second derivative is positive, right? The second derivative is positive. This means f is concave up. The second derivative is negative. This means it's concave down, right? Concave down. And we have learned this means we know how to find the where is f increasing, decreasing, concave up, and concave down. Maybe concave up. This means the graph is shaped like a cup, like this. This is concave up, and here like this is more like this is concave down. And today we will learn here this is the inflection points. Inflection points. Let f be continuous at C. What you say? At a point C, we call CFC an inflection point of the graph of f. If it's concave up, it's concave up on one side of C and concave down on the other side. This means the graph in figure 17 indicates a number of possibilities. Here, this is f is continuous at C, and f is concave up. This is concave up on the left side of C, like a cup, so it's concave up. And the right side we find is concave down. So this point is CFC. This point is an inflection point, right? This is an inflection point. And so here, the C1, this is C2, the C2, the left side is concave down and the right side is concave up. So C2F2 is also an inflection point, right? Inflection point. In Chinese, it's called inflection point. It's called inflection point. It's called 拐点. Inflection point. And here, this is another inflection point. Inflection points. Okay, where function's minimum or maximum is a number, an inflection point is always an out of the pair CFC. Okay, so this is different from the maximum and minimum. An inflection point is an order is an out of the pair CFC. If some students always write the inflection point like this, C. It's not a C, it's CFC. Okay. And next, we will learn how to find the inflection point. As you might guess, points where f double prime x is 0 or where f double prime x does not exist are the candidates for points of inflection. We use the word candidate. This means here we will know how to find the inflection point. We first will find the candidates for points of inflection, and then we will make sure if it's an inflection point. Just as a candidate for practical office may fail to be elected. Okay? So, for example, may a point where f double prime x is 0 fail to be a point of inflection. Consider f(x) is x power 4, which has a graph shown in figure 18. This is f(x) is equal to x power 4. This f double prime x is 0 fail to be a point of inflection. We'll find f double prime x. F double prime x is 12, right? 12x squared, right? Because f prime x here, f prime x is 4x cubed. So f double prime x is 12x squared, right? 12x squared. And we like f double prime x is 0. This is 0. We can find the x is 0, right? So the point x is 0, f0, f is equal to 0, 0, right? Here, 0, 0 is orange, this. And we can see on the left side is concave up, and the right side is also concave up. So 0, 0 response is not an inflection point, right? Inflection point, this means one side, this is F is concave up on one side of C and concave down on the other side. Just the one side concave up, the other side concave down. This both sides are concave up, so 0, 0 is not an inflection point. Therefore, in searching for inflection points, we begin by identifying those points where f double prime x is f double prime x f double prime x is 0 and where f double prime does not exist. And then we check to see. We should check to see if they really are inflection points. Okay, inflection point. Okay. We have example 7. Then find all points of inflection for f(x) is x power 1 over 3 plus 2. And we should find here, we should find f, the first derivative, f prime x is 1 over 3x power 2 over 3 and f double prime x is this one, right? And then we can, if we like f double prime x is 0, we can say f double prime x is never 0, right? It's never 0 here because it's equal to minus 2 over 9x 5 over 3. It's never 0. It's never 0. And however, it fails to exist. X is 0. This means Vx is 0. The second derivative does not exist. And the point, we'll take the point 0, 0 f0. F0 is equal to 0, 2. 0, 2 is an inflection point. Since f double prime x is greater than 0, for x is less than 0. This is here, this is 0, 2, this point, right? 0, 2, we will find the left side. We take it is left side f double prime x is greater than 0. This means on the left side is continue up like this. And so in the find we x is greater than 0, f double prime x is less than 0. This means here on the right side is continue down, right? Less than 0. So on one side concave up, on the other side concave down. This means 0, 2 is an inflection point, right? Inflection point. So we have 0, 2 is an inflection point. The graph is sketched in figure 19. 0, 0, 2 an inflection point. We check eight. How to check it? We should find f double prime x the sign of f double prime x on the left side and the right hand side. If they are one side positive, the other side negative, then this point is an inflection point. Exam 7. Any questions? I'm not sure if you can hear me because there is a lot of voice. There is much noise. No question. Okay, no question. How did you find 0? Here, this means you should find the candidates. Here, this one. You should find the candidates for points of inflection. Candidate. What's a candidate? This means candidate. This means here this is where f double prime x is 0. F double prime x does not exist. Does not exist. We find from this we find x0, x1, x2, for example. Here, these points are candidates. But the candidates is not candidates may fail to be elected. Okay, candidates may fail to be elected. So we should check it. And for this one, it's not so there is always there. No, you should ask 0. This is f double prime x is 0 or f double prime does not exist. Okay, it's not always 0. No, it's not always 0. You solve the first equation for x and the second condition. You find, for example, you find x0, x1, x2, x3. These points are candidates. These points are candidates, and they may fail to be elected. So you should check it. Okay, you should check it. For example, exam 7. We find f double prime x, but it's never 0. So the first candidate, this is 0 because it's never 0. So from this equation, we cannot find any candidates, right? And the second condition is f double prime x does not exist. So we can find does not exist. This means Vx is 0 here because x in the denominator. So we find x is 0. F double prime x does not exist. So the candidate is 0, 2, only 0, 2. Now we will take 8. How to check it? We will find 0, 2. The left side is concave up. The right side is concave down. So this means one concave up, the other concave down. So the other two is inflection point. It's an inflection point. Any questions? Hello, any questions? Okay. Okay. Now this is not. I think this is still not homework. Okay, we will give you homework later, but it's not homework. I just want you to finish number 2, number 5, 16 right now. Okay? Number 2 is in problems 1 to 10 use the monotonicity theorem to find where the given function is increasing and where is decreasing. Where is increasing and where is decreasing. And in problems 11 to 18, use the concavity theorem to determine where the given function is concave up and where is concave down. Also find all inflection points quickly. We have 3 questions quickly, okay?
ناري ماما عاد خواصة شحال خايبة تقولي مصاوبينها بالسمن كرواسة ماما ثقيلة If you finish that, you can send your answer to me to our meeting, okay? Or Simu, let's say.
Yeah, right. Ashway is right. 12x that better 6x plus 12. So it's 12. Okay, yeah, you're right. So we can find is x minus 1. Positive, negative, positive, negative, positive. So increasing, decreasing. Oh, great. – 16. Quickly, 16. I want to see the answers for 16. 16, you find all inflection points is 2, 5, right? Hello? 16. Five minutes. Okay, 5 minutes. Okay, okay. Oh, I see Lily's answer. That's right.
Lily, I saw your answers. I think all are right. Now, 16, quickly. Sixteen finished. Quickly. Concave up, concave down, inflection points. Huh? Oh. Inflection points. Okay, and we will give the answer. Here, I will show it for you. This is Fashimu's answer. Fashimu's answer like this. Oh, here, this is the. Hello, I think you can say his answer, right? Here, this is wheel is increasing and decreasing. We find G prime x is 2x minus 1, right? And Vx is greater than 1 over 2 is increasing. And less than 1 over 2 is decreasing, right? It's decreasing. It's decreasing. And number 5, we have find G prime x. G prime x is equal to 6x power x squared minus 18x plus 12. Factoring x minus 2, 6x minus 6, right? Then Okay, and this x minus 2, 6x minus 6. We can find this 1, the split points 1 and 2. So we can find this minus infinity to 1 increasing is positive, right? To infinity is positive. So increasing interval is minus infinity 1, you need to infinity. And g prime x is less than 0 when on the interval 1, 2, right? 1, 2. Okay, so 2 and 5 we finished. And the next, this one. Yeah. 16. F prime x is 4x cubed plus 24x squared. F double prime x is 12x squared plus 48x. So F double prime is greater than 0. This means 12x squared plus 48x is greater than 0. Factoring. Here, the split points are minus 4, 0. Hello, Fashimu. Here, the interval, this here. This should be minus 4. Minus 4. And we find minus infinity to minus 4. This is f double prime x is positive, so concave up. 0 infinity, concave up. Okay? And we find minus 4, 0, concave down, right? So please tell me the inflection point. We can find the inflection point here. This is minus 4 at this point. The left side at this point, the right side is concave up. The left side is concave up. Right side is concave down. So minus 4, f minus 4 is an inflection. Also, 0, f0 is also an inflection point, right? We have 2 inflection points. 2 inflection points. Let me see Lily's answer. Yes, but why? Why don't you give me the inflection points? Please don't forget to write the inflection points. Okay, here is the font. Here, find all inflection points. We have two inflection points. Okay, next we will learn the local extreme and extreme open intervals. We recall from section 3.1 that the maximum value. Yes, right. And 0 f0. We have 2 inflection points. Our function f on our site S is the largest value that f obtains on the whole intervals. Whole intervals is sometimes referred to as the global maximum or the absolute maximum value of f. Thus, for the function f with domain as here is AB. Domain AB, whose graph is crossed in figure 1. FA is a global maximum value. Here, FA. FA is a global maximum value. But what about FC? Like this one, this is FC. FC, it may not be king of the country, but at least is chief its own equal locality. Okay, We call it a local maximum value or a relative maximum value. Here, this one, this is a relative. This is the CFC is a relative. Oh, sorry. This FC is a local maximum value. This means we can find an interval, find a small interval. You can find a small interval. On this interval, FC is a maximum value, right? So this means local maximum. Of course, a global maximum value is automatically a local maximum value. Here, global maximum, also local maximum. Figure 2 illustrates the number of possibilities. Note that the global maximum value is simply the largest of the local maximum values. The global maximum values is the largest. The largest maximum values of the local maximum values. Similarly, the global minimum values is the smallest of the local minimum values. Of course, because it's global, right? It's global. Here is a formal definition of local maximum and minimum. We can write the symbol. This is intersection, denotes the intersection of two sides. We have let S, the domain of F, contain the point C. We see that here FC is a local maximum value of F. If there is an interval AB containing C such that FC is the maximum value of F on AB intersection S. Okay, this is local maximum value. There is a subsection or an interval AB containing C such that FC is the maximum value of F on AB intersection S. And FC is called a local minimum value of F if there is an interval AB containing C such that FC is the minimum value of F on AB intersection S. And the last one is FC is the local extreme value of F. It's a local extreme value. If it's either a local maximum or a local minimum value. Now we will find where do local extreme values occur. Where? Okay. The critical point theorem goes with the phrase extreme value replaced by local extreme value. The phrase is usually the same as the critical points. This means end points, stationary points, singular points are the candidates for points where local extreme may occur. We say candidates because we are not claiming that there must be a local extremum at every critical point. The left graph in figure 3 makes this clear. However, if the derivative is positive on one side of the critical point and negative on the other, then we have a local extremum as shown in the middle of the middle and the right graph in figure 3. And this means if the function is continuous, we have this conclusion here like this. The first one is no local extreme value. Because here there's the slope, the left side the slope is positive, right? The slope or the derivative is positive. This means f is increasing. And the right side is still increasing. So at this point, the slope here, we have this slope is 0. Slope is 0. So no local extreme. But here, we have local maximum. Because at C, at the point C, you can the left side f is increasing. This means f prime x is positive, it's increasing, and the right side we find f is decreasing. This means f prime x is negative. First increasing and then decreasing. Now, at this point, we will find it attains local maximum value, right? It's easily to understand because first increasing and then decreasing. So at this point is this one. At this one, this FC maybe we have local maximum, and here we find this is the local minimum because on the left side is decreasing like this, decreasing, and then our right side is increasing. So at this point, it is local minimum value, right? And this finger through this one, the second graph, first increasing, then decreasing. So at this point, it is local minimum, local maximum value, right? So it's then we will give the how to. This is how to work. It's how to. This is where do local extremes occur. We have theorem A. This means first the derivative test. First f be continuous on an open interval AB that contains a critical point. If we find if f prime x greater than 0 for all x in AC and f prime x less than 0 for all x in CB, the FC is the local maximum value of f. Right here. This is F, this is C, and C. And for example, this is A, this is B. We analyze I. F prime x is greater than 0 for all x in AC. This is AC. F prime x greater than 0, this means F is decreasing or increasing. F prime x is a positive, is increasing or decreasing? It's increasing, right? Increasing like this. Increasing. I see. And F prime x is negative. It's negative for all x in CB. So this means it's decreasing, right? Increasing, first increasing, then decreasing. We can see from this local maximum value, right? So FC is the local maximum value, and the second this is opposite. First decreasing, okay. First decreasing, then increasing. So at this point, it attains minimum value, right? Local minimum value, and the last one is if our prime x has the same sign on both sides of C. It means here this is C has the same sign on both sides of C. For example, all positive. Positive, this is A, this is B, all positive. This means positive is increasing, right? CB positive, also increasing, right? So it FC is not a local extreme value, right? It's not a extreme value of F. I hope you understand theorem A. And example 1, we will use theorem A to calculate example 1. Is find the local extreme values of the function on minus infinity to infinity. Local extreme values. Local extreme values, this means you find if they have, you should find the local minimum and local maximum values. Right? So if we want to use the theorem A, first the derivative theorem. Theorem A is what? First the derivative test. So we find F prime. So first, the f(x) is a polynomial function. So f is continuous everywhere, and its derivative is f prime x is 2x minus 6, right? This exists for all x. Thus, the only critical point for f is a single solution, f prime x is 0. That is fx x is 3. Maybe you have a question why we want to find the critical point. Here, why we find the critical point. Here. This one. Also we have critical points because why we find critical points by this theorem. By theorem B is critical point theorem. This means f be defined on an interval I containing the point C. If f C is an extreme value, we want to find the extreme value. Then C must be a critical point. Right? Now we want to find local extreme value. Yes, I just review it. Why? Last which one? I review it and then I finish it. What? Yes, we didn't read this. I want to first explain it and then finish it. Okay, I just explain how to find the local extreme. Why we find the critical points. Okay, why we find the critical points. This means if FC is a critical point, this means C must be. If FC is a local extreme value, this means C must be a critical point. So that's why. That's why we want to find the critical point, right? That's why we want to find the critical point, because if it's a local extreme values at C must be a critical point. So we first find the candidates. Okay, we find that all critical points. We have only 3. This is 3. And since we find prime x is less than 0 for x less than 3, right? Less than 0 for x less than 3. This means f is decreasing on minus infinity to 3. Decreasing, right? Decreasing. And B, because it's greater than these 3, prime x is positive, so it's increasing. Therefore, by the first derivative test, we find f3 minus 4 is a local minimum value of CF, right? Local minimum value of f. And since 3 is the only critical points, there are no other extreme values. The graph of f is shown in figure 4. Note that f3 is actually the global minimum value in this case, right? It's not only a local, it's a all real line, global, right? It's global. So, okay, example 1. Any questions for example 1? No. This means if you want to find the local extreme values, you should find all the critical points, including stationary points, endpoints, and singular points. And now this is theorem A, the first derivative test. Now we have the second derivative test, the theorem B. There is another test for local minimum and maximum that is sometimes easier to apply than the first derivative test. It involves evaluating the second derivative at the stationary points. We want to find the second derivative. It does not apply to singular points. Okay, it does not apply to singular points. We have theorem B, the second derivative test. Let a double prime exists at every point in an open interval AB containing C. And suppose that f prime C is 0. This means C is the stationary point. Stationary point. If we find f double prime C is less than 0, then f prime C is the local, the maximum value of f. If it's greater than 0, the fc is the local minimum value of f. Okay, this is the second derivative test. This means you should remember right. Every theorem A. If you don't know how to use theorem B, the second derivative test, maybe you just remember theorem A. It can solve any problems. Okay, you can just remember this one. And if you know example, if you maybe you think you are good at math, you can also remember theorem B, the second derivative test. Okay, second derivative test. This means if you know theorem A, you can solve this problem. Okay, you just use theorem A, you can solve it. And also we just introduce another method. This is called theorem B, second derivative test. Okay, this means, but here it does not apply to singular points. You can find theorem B is more easier to find the maximum, local maximum value and local minimum value. But this means not all problems can be solved by theorem B, but it can be solved by theorem A, right? Okay, you should know right. Not every problem can be solved by theorem B, but they can be solved by theorem A. Okay, we have theorem 4. For fx is x squared minus 6x plus 5. Use the second derivative test to identify local extreme. Here, this is the function of example 1. Okay, this means this is example 1. Example 1, we use first derivative test. We have solved the local minimum and local extremum, right? Now we use method 2, the second derivative test, to calculate it again. Okay, and we first find f prime x is 2x minus 3, and f double prime x is 2, right? F double prime x is 2, and thus we find. Please tell me the stationary point. Stationary point is stationary point. Do you know stationary point? Stationary point. Here the STATIONARY. This one stationary point. This one stationary point is 3, right? We left this is 0. The stationary point is x is 3, right? X3. And then we will check yes, x3. We use theorem B. So we should check f double second derivative, f double 3. F double 3 we find is greater than 0. Okay? F double prime is greater than 0. This means F3 is local minimum value, right? F3 is local minimum value. Okay, we'll find F3 is F3. They just plus 3 square minus 3 plus 5. The local minimum value. Local minimum value. Okay, this is so you can find for this for this function, it's easy to use the second derivative test to calculate the local minimum value, but not all questions can be solved by theorem B. But it can be solved by theorem A. Now we have this extremer on open intervals. The problem set we studied in this section and in section 3.1 often assume the site on which we wanted to maximize or minimize a function was a closed interval. However, the intervals that arise in practice are not always closed. They are sometimes open or even open on one side or on one end and closed on the other. We can still handle these problems if we correctly apply the theory developed in this section. Keep in mind that maximum with no quantifying adjective means global maximum, right? Okay, maximum means global maximum. Okay, exam 6. Maybe you should do by yourself. Exam 6. Find if any exists the minimum and maximum values of fx. Okay, I say Lily's answer. fx power 4 minus 4x. X prime x is 4x cubed minus 4. I want the minimum and maximum. Wow, I'll send. Okay, I see your answer, Lily. Okay, here is the Fashimos. Let's read it. This is to find the minimum and maximum values. This means you should find the global maximum and the global minimum. Okay, let's see Fashimos. Here, this is Fashimos answer. What are you doing? Put down your phone quickly. Really? What are you doing? And we can have Fashimo calculate prime x is 4x cubed minus 4. F double prime x is 12x real. Let prime x is 0. We find x is 1. And vx is 1. F double prime y is 12. X is 1. This is the only critical point, right? The only critical point. So for x is 1, we can find the minimum value because f double prime y is 12. So this means f1 is the local minimum value, but only one local minimum value. This means it's global minimum value. So we find f1 is -3. This is the minimum value. And this means does not exist maximum value, right? Okay, any questions for us? No. Okay, wait. Next. Yeah, 明白了。Okay. Exam 2. And here only. It must actually be the minimum value of f. F cannot have a maximum value. And now we will learn the mean value theorem for derivatives. In geometric language, the mean value theorem is easy to state and understand. It says that if the graph of a continuous function has a non-vertical tangent line at every point between A and B, then there is at least one point C on the graph between A and B, at which the tangent line is parallel to the secant line AB. Here, like this. This is AB, a second line. There is no vertical tangent line at every point between A and B. Then there is at least one point C. When at least one point C on the graph between A and B, at which the tangent line is parallel to the second line. Here, the tangent line is parallel to the second line AB. In figure 1, there is just one such point C, but in figure 2, there are several. First, we state the theorem in the language of fractions. Then we prove it. Here we find at this point C1, we have a tangent line, C2 tangent line, and this tangent line. This is parallel to the second line. We have 3 tangent line. And then this is the mean value theorem for derivatives. This means f is continuous on a closed interval AB and differentiable on its interior AB. Then there is at least the one number C in AB, where we have is FB minus FA over B minus A is F prime C. Or equivalently, where we multiply both sides by B minus A. So we find is FB minus FA is F prime C, B minus A. But how to understand this theorem A? Because from this, I know. Here, if A, we have, this is A, this curve, we have the function is y is fx. Y is fx. A, we have the coordinate is AFA. Here, this B, we have, this is BFB. And we have 2 points, A and B. So we can find the slope of this straight line, right? The slope is equal to second line slope MK. Second line is equal to R is equal to FB minus FA over B minus A, right? This is the slope of the second line. And because at C, we can find a point C such that the tangent line is parallel to this second line. So the slope of the tangent line, if the equation is y is fx, so the slope, this means is f prime at the point C. Because they are parallel, so they have the same slope. This means f prime C is equal to f prime C is equal to FB minus FA over B minus A. And here this is at least. This means it's not only one, it's at least 1 point. At least 1 point. Okay, and our proof rests on a careful analysis of the function. We will construct a new function, Sx, right? Sx is equal to fx minus gx. Introduced in figure 3. Here, y is gx is the equation of the line through AFA, BFB. Since this line has slope, this line, this black line, this line has slope. This is gx has slope of B minus FA over B minus A, over B minus A, and goes through AFA. So the point slope form for this equation is this is the slope. This is the fixed point. So by the point slope form, we can find this is gx minus fa is equal to slope times x minus a. From this, we can find the gx, right? We can find the gx, okay? Gx. And then this in turn is a formula for Sx. No, Sx is equal to, because we have here, the Sx is equal to fx minus gx. Sx is equal to fx minus gx is equal to fx minus, here, this is the gx. We get it by the point slope form. And now note immediately we find SB. We calculate SB. Yeah, SB here. SB is equal to, this means X is B. So it's FB minus FA. FB minus FA minus FB minus FA over B minus A times B minus A. This is SB, right? You can also calculate SA. SB, You can simplify it. It's equal to B minus A cancel. So it's FB minus FA minus FB plus FA. Right? Plus FA. So it's 0. It's 0. Fx minus gx. Fx minus gx. Right, fx minus gx. Fx minus gx. So we find SA is 0, SB is 0. Let's write for x in AB. We find S prime x. We take a prime is F prime x minus this one. Now we make a crucial observation. We knew that there was a number C in AB satisfying F prime C 0. We would be all done. Then for the last equation, we would say that F prime C is 0, which is equivalent to the conclusion of the theorem. To say that S prime C is 0 for C, for some C in AB, reason as follows. Clearly, S is a continuous function on AB, being the difference of two continuous functions. Thus, by the max minimal existence theorem, S must attain both the maximum and minimum value on AB. If both of these values happen to be 0, then Sx is actually 0 on AB, and consequently S prime x is 0 for all x in AB, much more than we need. Maybe the purpose is long. I think it's really hard for you to understand it. Maybe you just understand the why like this. You understand the result, right? From geometrical respect, you should understand this. Here, this is because the signal line. The signal line like this. So you can, from this graph, we can find a point, right? They are parallel. So by geometrical perspective, this is the mean value theorem for derivatives. Okay. And the one example, find the number C. Number C guaranteed by the mean value theorem for fx is 2 the square root of x on 1 for number C. Here number C is unknown. Number C, fx is 2 the square root of x. So we find f prime x. Calculate f prime x is 1 over the square root of x. And we want to find the number C. This means we want to find this is from 1 4 by the mean value theorem. Mean value theorem. This is AB. We write the solution. The solution is FB minus FA over B minus A is equal to F prime C, right? F prime C. The left side is the slope of the second line, and the right side is the slope of the tangent line. They have the same slope. And here, this means A here, and Fx is 2 the square root of x, right? So here we write FB minus FA. FB is F4 minus FA is F1 over B minus 1. 4 minus 1 is equal to F prime. F prime x is 1 over here, x replaced by C, right? X replaced by C. Now we solve this equality. Solve this equality. F4 is 4. F4 is 4. F1 is 2. Here is 3. So it's 2 over 3, right? 2 over 3 is equal to here 1 over the square root of c. From this we find the square root of c is 3 over 2, right? 3 over 2. So we find the c is 9 over 4. We just use this solution. Use the result. Final result. We find the c. Do you understand this? Hmm? Any questions for example 1? No. Fascimo only. Fascimo, Lele. Always this to student. You just remember the mean value theorem to suss the slope of the second line is equal to the slope of the tangent line. It's f b minus f a over b minus a is f prime c. Right? It's f prime c. So it's equal to here f4 minus f1 over 4 minus 1 is 1 over the square root of c. And we solve this equality, we find the c is 9 over 4. Here, maybe example 2, have a try. Example 2, have a try. What? The formula. Mean value theorem, right? Maybe you can use your phone because when I turn back, or you just want to write the result. Here, this is the mean value theorem for derivatives.
ما في غلط بعد بكيش بيه انجليزي بعد من التيس وصافي عطيني اشبر التيسان وعطيني اشبر التيسان على نجينا هي عطيني التيسان الله يحفظك صافي كي تكون تمكا ما كاين حتى كنت مكت بعد مني بعد وصافي بعد وخليه صافي وصافي وخليه واشغل هو من 11 صافي بعد مني انت وخليه بعد تروح انا معكم وحافظ انا كاع انا بعد مني الله يحفظك ابعد مني انا كندير السب انا ما كنحفظ ما كنخرب لا بلاتي ما بغيتش نجلس ولا صافي بعد مني
هذا نونو سكر مويتي شو
ما شغليش بعد مني مشي وصافي خليه يدير اللي يبغى وصافي خليه يدير اللي يبغى خليه صافي وصافي
So now we can show the rounds. Okay.
كنحفظ كاع بعد مني جلس ما كاينش كاع
Lao Shi, yeah, I'm here. Check your what? MSG. Your MSG. What's MSG? Here example. This is answer. Find all message. Okay. Later. Okay. Find all numbers. Okay. I know. Find all numbers satisfying the conclusion to the mean value theorem. Then we can say, first we find a prime. Here the interval the interval is -1, 2. A prime x we find to this one. So fb minus fa over b minus a. This is the left side, right? Is equal to f prime c, right? F prime here. This is 1. Is equal to f prime c. 3c square minus 2c minus 1 is 1, right? This is f prime c. 3c square minus 2c minus 1, right? And then this is equal to 1. This is equal to 1. And we solved 3c squared minus 2c minus 3 is 0, right? This is 0. And by the quadratic formula, there are two solutions which can correspond to C1 is about minus 0.55 and C2 is about 1.22. Both numbers are in the interval -1, 2. Okay, we can find it. We can find the C1, C2. So we solved it. I think it's easy. It's just difficult to prove this theorem, but the solution is easy, right? The result is easy to understand. Hello, bye-bye. See you now. Tomorrow night.
الله يا أستاذ في الله.
Lily. Okay, bye-bye. Oh, Lily is right. Okay, Lily.
شكرا
Right,
دخول
I see your
هذا.
answer. I think it's right. Bye-bye.
بس عملنا
لا غير هذاك learning new English word